Hello, good evening, everyone.
Good evening, sir.
Good evening, sir.
So, hey,
Evening, sir.
Hi, sir.
good evening. Who are we expecting? Is everybody I have logged in now? Belakpo, who are we expecting?
Sir, Chizobam is not here, sir.
Huh?
Chizobam, she's not here.
Okay. Who came to my office today? Who checked me in the office today?
Sir, was he a female?
Yes, he said she checked me in the office today.
She's
Then,
probably the one, sir.
okay. Okay, anyway, we will start. I'm trying to delay to ensure that everybody is around, but we can't wait for her. Hello?
I'm hearing you now, sir. We
Yes,
couldn't
sir.
hear you before.
Yes. I tried to mute it. The former DD, Professor Luce, he called me, so I have to attend to him. Do you know him?
No, sir.
You don't know him? Okay, he was the former deputy director in Maritime then.
Oh, I think I know him, sir.
So he's the one that called me now. Okay, let's just move forward. I think we stopped here last time. Who can remind us where we stopped? We are looking at balanced water. And I think I gave you 2 assignments to be submitted next week. Am I right?
Yes, sir.
Yes, sir.
Good. Hope you are through with the assignment.
Yes, sir. Almost done, sir.
Okay. Okay, so we're saying that how is balanced water a pollutant? One, we need to understand that no matter how it's being screened, there's tendency for bacteria, microorganisms, and even algae to have their entrance into the ballast or into the tank. And that would be a major issue when they're offloading the water in another region or in another country. Most of the indigenous species may be carried along, and it will be a problem in the new area in which they are being released into. One, they begin to cause a kind of conflict with the natural or indigenous species. Not only that, there is a tendency that they can even wipe away the indigenous species and establish themselves. It depends on their strength, to be able to do that. So we said that various life stages of aquatic plant and animals species are also transported because they are very small in nature. They can escape the screening processes. So ships traveling in Nigeria, for example, in Nigerian water, for example, carry thousands of tons of balanced water annually, making Nigeria vulnerable to the introduction of alien species from the balanced water discharge. So you see that any foreign water coming into our water body, the species are vulnerable because of the alien species being introduced. Now, what are alien species? Now, we say that those that are not native to a given ecosystem, and they are also called exotic species, or non-native species, or non-indigenous species. When is an alien species considered to be invasive? We say that only when they cause or are likely to cause harm to the environment, not only to the environment, to the economy and human health. The introduction and spread of alien invasive species is a serious problem because its impact on ecology, economy, health, and the environment as a whole, which include the loss of biodiversity because they will actually change the total ecosystem. So generally, the impacts depend on the origin of the organisms and the location of the point of discharge. And majorly is being discharged very near to the shore. Very near to the shore. Marine invasive alien species, which we call IAS. And we made to understand that according to Molnar et al. 2008, a species transported outside its native range and introduced to areas where it does not naturally occur may, under suitable conditions, become established. And in the absence of natural control, that is, maybe we have predators that will eat them or parasites, can drastically change the ecosystem. It can change the function of the ecosystem and also change the species composition. So, and that's what they are referred to as alien species. We are going to give some examples of those alien species later on. So such species are referred to as invasive alien species. These species are non-native to the considered ecosystem and causing or can cause economic and or environmental harm or harm to human health. IAS has been reported as one of the most significant threats to global diversity. It's a serious threat to global diversity. Most aquatic habitats are particularly vulnerable. That is, for example, in mixed island system, in lakes, rivers, near shore marine systems. So they make the aquatic habitat vulnerable when they are in these systems or in this ecosystem. The vulnerability of this aquatic ecosystem is partly due to biological and physical characteristics of this ecosystem. Then secondly, human activities. Species are at times introduced intentionally. For example, in aquaculture. Very recently, not too, maybe around it's more than 3 years, maybe around 5 years ago, some people introduced a particular fish species into the water body, into our, brought into Nigeria for aquaculture. We call this pangasius. And it's not native to Nigeria. So if those species escape into our water body, there's tendency for them to actually cause harm into the environment. So also crayfish or carp, which we call superior carpio, it brought, from Asian country in the early 50s, and they were rearing them in jaws because of the climatic condition. The climatic condition of Plateau State is so suitable for culturing of carp. So when those ones escape into our water body, they can cause biodiversity and change or result in lost biodiversity of the ecosystem. So also associated with fishing or recreational yachting or driving, all these can contribute to loss in biodiversity. Then, however, shipping is the main vector for species transport and responsible for the majority of marine species introduced. Ship carries about 90% of world trade in volume and move an estimated 10 billion tons of balanced water globally each year. So in essence, you see that there is serious transportation of water from one location to the other. And there is tendency for all these alien species, invasive alien species, to be transported with them, which will cause problem to the ecosystem of the region where the water is being released or is being offloaded. So the water contains multiple of life organisms, estimated up to 7,000 species. 7,000 species around the world. So when you have 7,000 different species being mingled, in all continents, too well that there is a problem, there is likely to be a problem with those ecosystems, and they may actually result in loss in biodiversity. The presence of these Africa's fishing in balanced water has become a major environmental challenge. And it is very important to know that containing or eradicating a marine species, once it is established, is nearly possible. Why is it impossible? Because they can actually swim and breathe in the water body or in the ecosystem. And from there, they can begin to migrate from one location to the other. So it is very difficult to eradicate or to curtail them. So management of marine IAS therefore must focus on precautionary measures, all the ones stated by IMO, and has been addressing the issue of IAS and balanced water since 1980. So since 1980, they considered that is a major problem. And you can read more in the Balanced Water Management Convention that I gave you. So you can read more on that. The economic of managing IAS, invasive alien species. The economic impact of IAS can be very large. For example, one of the worst marine species invasion occurred in early 80s. And that actually prompted the IMO to actually come with their precautionary measures and also policy. When the North American cup jelly was introduced into the Black Sea through balanced water, it actually causes a lot of losses to America at that time. It rapidly took hold, and by 1989, that is 9 years after, an estimated 1 billion tons of alien species was consuming vast quantity of fish eggs and larvae. So invariably, the fish species and larvae in America at that time were wiped away. Why? Because of the alien species. So also the zooplankton, which is the primary producer, that, fish will feed on, it also attacked them. So zooplankton that commercially important fish feed on were also attacked. Now, this is the jellyfish we are talking about. This is how you look like. Hemiopsis leydi. This is how it look like in the water. But you also see it clearly in the next picture. This is how it look like moving in the water. But when it's being brought out, this is how it look like. So it actually causes a lot of economic loss in America in 1980s. And now look at the movement. How it actually moved from one location to the other. When there is transportation, and this is how, the movement actually goes. And moving from area like this in they experienced it in the North Sea, maybe in 2006. By 2008, it's already here in the Black Sea, and also in Caspian Sea by 1999. So you can see how it actually moved from one place to the other, causing economic losses. So this is the spread of cup jelly. So by 1992, the annual losses caused by drop in commercial catches of marketable fish were estimated to be at least $240 million US. So it was estimated after around 12 years that at least they actually lost $250 million because of invasive alien species. Therefore, successful managing RAS can provide long-term economic and environmental benefits, which include conserving biodiversity, health of ecosystem, and maintaining the services they provide. Therefore, a strong case for strategic investment in prevention rather than post-invasion damage control is the best strategy. So it's better to prevent, the introduction of invasive alien species in our environment than treatment. And the general saying that prevention is always better than cure. And, they were able to publish that for any reason, because of the losses, that comb jelly are not wanted in all their regions. So there was serious screening in America, I think till now, for this particular species, because they actually lost a lot when it was invaded into their water system. Now, I told us about the Noah's Ark. In those days, different kind of species. God told him that at least two of the species should come into the ark. I don't want to talk more on this because I've given you the assignment. So go and read and do the assignment. Now, these are the process of releasing the water at the shore, maybe when they want to load the vessel. And these are different species that are moving from one region to the other. They are being caught in the process, knowing too well that they are not indigenous species. So serious precaution must be taken to ensure that the invasive alien species is not released into our water body. Now, this is another one we call the Nepal palm seed. Nepal palm seed was also transported, and it caused a lot of problem in some regions. And it wiped away the natural vegetation in the new area where it's being carried to. So it's also an alien species. Now let's look at balanced water management. BWM. Balanced water management can involve various processes, namely mechanical, physical, chemical, and biological. Each process could be either on their own or in combination. And what is their aims? What is the aim of balanced water management? Their aim is one, to remove unwanted species and render them harmless. Render them harmless, minimize the uptake or discharge of harmful aquatic organisms and pathogens within balanced water. So these are the aims of balanced water management. Now let's look at balanced water exchange. Balanced water exchange. This is the mid-ocean balance exchange. are 20 nautical miles from shore in water that are at least 2,000 meters deep. Now, water are expected, if at all they want to release it, it must be at least 20 nautical miles away from the shore. But most of the vessels are not actually following this. And that's why we have most of the invasive species in most of the region. So it is the best available option to reduce the alien species introduced and transfer. However, the process has various ship safety issues. For example, two common approaches to balance water exchange. We have what we call sequential exchange and flow-through exchange. Now, what is sequential exchange? Sequential exchange requires balanced water to discharge until when the tank is empty. That one can also be done at 20 nautical miles away from the shore. This can compromise ship safety and maneuvering in the sea. So the reason why a lot of vessels are not, doing sequential exchange is that it will make the vessel not to stabilize. It will destabilize the vessel. Also, half-filled or empty tank with water sloshes back and forth and creates heavy impact on the hull and bulkhead in addition to affecting stability. And sometimes when they say, okay, let's just release some and put more, it can also result in affecting the stability. But it's also a method that is recommended. Then there is another method recommended which we call flow-through exchange. Now this one requires an entry and exit for flow. Now by the time they get to 200 nautical miles, they release the water, and at the same time, they will be taking the water as they are moving, they will be taking the water from the sea or from the ocean into the tank, and at the same time, releasing it out. That method will enable the vessel to have a little stability until when they get to the shore. So flow-through exchange requires an entry and exit for flow. With this, water is simultaneously added to and discharged from the tank. It does not greatly affect ship stability. So we must understand the difference between the sequential exchange and flow-through exchange. Now look at this diagram of balanced water management. They also have some mechanism in order to ensure that, okay, the rate of water flow in and out. And these are the mechanisms. And they have some processes to also checkmate the introduction of microorganism, bacteria, and other species. So this one shows the during intake, the processes, how the balanced water is being filled into the tank. And the second one also shows how it's being released into the water body from the vessel. Now, this diagram shows how the balancing and debalancing and the processes. Now, for the balancing, that is inboard water that is taking in the water Look at where the cursor is. It has what we call neutralizer or neutralization unit. It's the process of screening before it also gets to another filter, and also before getting to a storing tank, who also help in screening the microorganism before it's being released into the tank, into the balance tank. Okay? Now, when it's being offloaded or released, the balancing is the same procedure. It passes through neutralizer. From neutralizer, because you want to release it, it may not pass through the filter. It will just be released directly overboard. So these are the processes or the mechanism of the operation of the balancing and debalancing. Now look at this diagram also. In the process, there's some screening ability, the filter unit. In the filter unit, removal of light plankton, then sterilization by ultraviolet. The ultraviolet kill most of the microorganisms. It kills most of the microorganisms before the water is being released into the balanced water. So those are the measurement or precaution that IMO put in place. Now, this is when you are also debalancing. You have a pump to just pump it out, but at the same time, it will pass through the ultraviolet light to kill most of the microorganisms. And it also have a treatment tank here that will also treat it before it's being released into the water body. Now, marine organisms in the seawater are returned to their habitat when the seawater passes through the high performance filter element. Sometimes when you are using flow-through system, it can flow in and out to ensure that at least the water is being filtered before it coming. So this is another process of balanced water. Small plankton and bacteria, including colon bacilli, contained in the filter seawater are treated by appropriate chemical agents and by mixing agitating in the vitreous tube. So all these are being treated before it's being released into the balanced water. And if you look at the filter, you say plankton up to 5 gram are returned to the sea. So it will screen it and it will flow back. And there are other treatments to ensure that microorganisms do not enter the balanced water. Okay. So any question on balanced water? Any question? If there is no question, let's move forward. Then we are just looking at the sewage pollution also, although we have actually mentioned it earlier on. But for emphasis, not less than 10 million gallons of sewage annually are being dumped into the sea. And this also can cause a lot of instability in the ecosystem if they are not being treated. Most of the effluent from factories, if they are not being treated, they can kill the microorganisms. Or you see most of the region where fish are just floating because of the chemical that have been released into the water body. And that's why before industries can release water body, there have been a regulation that indeed it must pass through the treatment tank. It must be treated before it can be released into the water body. Now, this is a natural, unpolluted water body. And you see, when the environment is not polluted, all the microorganisms, they will be freely moving and they will multiply. But the moment there is anthropogenic activities that destabilize the system, it makes the food chain to be distorted. Now, if you look at this, it has a perfect food chain. It has a perfect food chain. And there is no any source of pollution in this water body. But look at another one where water is polluted. Now, can you see the difference between the two? The source of pollution, how they, change the food chain and destabilize the ecosystem. So this is the effect of releasing pollutants into the marine environment. Now look at another one where sewage and industrial pollution sources, how they actually come into the water body from different sources if they are not treated. And it causes a lot of instability in our water body. Now, look at this raw sewage being released. Merely looking at the color, you agree with me that this one is releasing serious pollutants into the water body. And this is what is being released in most of the beaches. And this one will kill a lot of marine life by releasing these raw sewages into the water body. So the raw sewage should be filtered before it's being released into the water body. Although you can see some animals coming, also in one way or the other, the water, and invariably other microorganisms or diseases can be released, which will be harmful to the ecosystem. This is another one being linked into the water body. Look at how it is and the effects on the water body. Now, look at the level of corrosion. This one is being embedded underground and is being released into the water body. Maybe in order to beat the agency, they make a tunnel underneath and release it into the ocean. And when it is captured, look at the level of pollution this one also causes in our water body. This is a typical example of Sierra Leone. Look at the level of pollution. And people are still living even nearby. And this one can cause a serious health implication to the masses. Look at the level of pollution. This picture was taken in 2013. But I don't know whether, there have been an improvement in this area. This is a serious eyesore. And this is one of their beaches in Sierra Leone. You can see the sewage and trash flow into the sea from this place. A typical example also, when we went to Ghana, is also, I will also discover something like this. And it's flowing into the sea. Now, in order to make serious, to prevent the pollution in the water body, years back, there was an environmental alert that sewage spill and runoff contaminated ocean. There was serious pollution at the beach. And it's now said that people should keep off from that environment due to the release of contaminant sewage into the beach. So it caused a serious problem years back before it was cleaned up. Okay. So any questions so far? Are you here or you just on the, you just think up and you are doing another thing?
Yeah, here, sir.
None for now, sir.
Well, yes,
Okay, no
sir.
question for now.
Yes, sir.
Okay.
No question, sir.
Okay, so this is where we are going to end the class. So submit your assignment next week and begin to prepare for
Next
the
week,
fifth,
sir.
next week, Tuesday. You can bring it to my office. My project student can come on that day. Hello, is my
Okay.
project student here? I don't know whether the person is in this class.
No, sir, this is IMS, Institute of Maritime Studies.
I know, yes, they've assigned one student for me. Maybe among your seniors.
Yes, yes,
The,
maybe. Yes.
yes, the person called me today. Okay, no problem. I've already given the person an appointment to see me next week.
Okay, sir.
So I will upload the recording so that you can go over it again.
Okay, sir.
So if there's no any question, I wish you all the best. Begin to prepare for exam and read all the materials that I gave you. Read them.
Okay,
And
sir.
that was a portion of question and answer. How many of you are open it? Have you seen that section?
Yes, sir. And balanced water. Yes, sir.
On balanced water, yes.
Yes.
So ensure you read it and you understand. So I wish you all the best. Please submit the assignment. Dolakpo, are you the one? One of you should bring it on Tuesday, but call me before coming.
Okay, sir.
Is that okay?
Yes, sir.
You called me before. So take care and God bless.
Thank you, sir.
Is this
You're
the end of
welcome.
is this the end of the teaching?
Yes,
No,
this is the end of the class.
not just for today. I mean, as in everything.
This is the end. We've done part 1, part 2. This is the end.
Okay, sir. All right,
Yes.
sir.
So just
Thank
begin
you.
to read.
All right,
Yeah.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Yeah.